Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 1614. Maximum nesting depth of the parameters. Given a valid parameter string s, return the nesting depth of s. The nesting depth is the maximum number of nested parameters. So, let us understand what is the depth means. See here, just assume there's a bracket like this. Now, what is the depth? I can say the depth is 1. Why we are saying this depth is 1? Because we have one open parameters and one closing parameters. So, its depth is what? 1. Again, we can take another example. 1, 2, 3, 4. Now, what is the depth? I can say the depth is what? 2. Why 2? Because we have one opening. Here is one opening and second opening. Now, again I'm closing, so it will be what? Here it is one opening, okay. Again here second opening. Here again I am minusing one, because this will be strike out, right? This will be strike out by this parameters, so it will be what? Again 1. Again here it will be 0, okay. So it will be 2. Fine. Now a tricky part. Now say, what is the depth of this parameters? Okay, let me simplify this. First of all, we are having a open parameters, okay. Just take this open parameters. Now, as of now, it is 1. The depth is 1. Again, there's a second opening parameters. As of now, the depth is what? 2. Here, as of now, the depth is what? 1. Because we are minusing 1. Because it is closed bracket, right? Again, here, it will be 0. Again, here, it will be what? Again 1. Because it is opening. Again, here, it will be what? Again 0. What's the maximum among this? I can say the maximum among this 2. So, what is the output? Output should be 2. Now, can you understand what is the depth? What's the meaning of depth, right? Now, let us go with this example. See here. First of all, there's a open bracket. Just put the open bracket. Then there's another open bracket. Okay. Now another close bracket. Okay. Now another open bracket. Okay. Now another open bracket again. Okay. Now again two closing brackets. Right. So now we want to find here there is a closing bracket, another closing bracket. So now we want to find the depth of this combinations. Okay, this combination of bracket. Okay, let us see. Initially it is 0. Now it is 1. Again 2 because it's opening. Again minus 1 because it is closing, right? Again it is opening, right? So 2. Again it is opening. So 3. Again it is closing, right? Closing means minus 1. So 2. Again it is closing, right? So it is 1. Again it is closing 0. So what is the maximum? I can say the maximum is 3. So what is output? It will be 3. That's it. Yes. Again we can take this example. Just come up with me. See here. First of all, there's opening bracket. Put here, and then a closing bracket, and then two opening brackets, and then two closing brackets. Again, there's a three opening brackets and three closing brackets. Right, right. Now, what is the depth again? Let us see. See here. Initially it is 0. Here 1. Here again 0. Here 1. Here 2. Here 1. Again 0. Can you understand? Just whenever there is an open bracket, I'm just placing 1, and whenever there is a closing bracket, I'm subtracting 1. Okay, and then here again 1, here 2, again 3, again here 2, 1, 0. So what is the maximum now? As of now, it is 3. So value is 3. Fine, fine. Okay. Now, by using this approach, you know how to do this problem, right? Whenever there is a opening bracket, we will plus 1 a variable. Whenever there's a closing bracket, we will minus 1 that variable, and we will take the maximum of that variable. Okay, so this is the simple approach, and also we can do this in stack. We can also do this in stack, like see here. Okay, now we can see with the stack approach. See here, this is stack. Let me write a stack. Now, first of all, see here, if this is the opening bracket, right? I will push this opening bracket. Now again it is what? Closing bracket, right? As of now, what is the length of this stack? I can say the length is, as of now, it is 1, right? 1. Now it is closing bracket, so strike out and pop it out, right? Again it is opening bracket. Just just put that opening bracket inside. Again there's open bracket. Put now, what is size? Size 2. But already the length is what? 1. The maximum length we had previously is 1. So update this as 2 because it's the maximum length, right? Okay. Now again this closing. Okay, pop it out. Now again this closing. Pop it out. Again this opening. Just put opening, put opening, put. Okay. Now again this closing. But before that, see here. Now the stack size is what? 3. update it because length is 2, but we got a better answer 3. So update it. Now again it is closing right. Pop it out. Again it is closing right. Pop it out. Again it is closing right. Pop it out. Now what is stack length? It is 0. That's all. That's all. We will terminate our loop. So this is the stack approach. See here also the length is what 3 and result is also 3. Okay, now it's time to come up with the time complexity and space complexity. What's the time complexity and space complexity for this stack approach? I can say the time complexity is O of n, but the space complexity is what? O of n, because we are using auxiliary space. Also, the time is n because we are traversing this one time, and whenever we add one element, we only process that only one time. If it is popped out, we don't even refill again, right? So that's why it is O of n. Okay. Now, what is the time complexity for the previous approach? This approach, like this approach. What's time complexity? I can say time complexity is O of n. What's space complexity? I can say space complexity is O of 1 because we haven't used any auxiliary space. Okay. So this is the optimal approach. But also we can do with the stack. That's what my point. Okay. Now let us see the code now. See here, stack is equal to empty list. Now m is equal to 0 for I in s. That if I is equal to open parenthesis, I will want to push the open parenthesis into my stack. Else I want to push what? I want to pop out the element in the stack. But why I am putting elif and close bracket? Observe carefully. There is so many characters may occur. There may be so many characters may occur, but our focus is what? Open and close. Right? That's what I am using this elif. Don't put else. Okay, it leads to the stack overflow error. Okay, sorry, stack underflow error. Okay, now m is equal to max of length of stack comma n. Okay, I am just taking the maximum length of the stack. Sorry, length of the stack and maximum values, maximum as the max. Okay, and returning the max. Right. So this is my first approach. Let me submit it. Yes, it is submitted successfully. Now going for the second approach, it is what? Just a variable approach. See here, I just declare a variable 0. Then whenever there's an open parenthesis, I will increment the depth by 1. Whenever there's a close parenthesis, I will decrement the value by 1. Okay, and then I will take the maximum of depth and result. Then I am just returning the result. That's what. Let me submit it. Yes. Hope you understand this concept. Thank you.